So hello everyone. Our topic was energy consumption of the furnace processes. And next slide please. Here you can see the furnace, and there are like for thermal oxidation and annealing processes up to 1,200 degrees Celsius, and we have 5 pipes in which different lots and recipes can be processed. And in one pipe there are space for up to 75 wafers, and our task was to find out how much energy is consumed per recipe in a specific pipe. So here you can see how much energy was, the energy consumption of one recipe. So you can see that the ramp up took the most energy, and in the end you have like a standby energy that is always there. It's about 6 to 7 kilowatts. Next slide. So the data which was given was just the recipe in one table, and we had to match the starting time of the recipe to the energy consumption which was given in another table. So we have the data to get the energy consumption of the recipe just divided. Okay.
Okay. Hello everyone. So the semiconductor manufacturing, it requires a lot of energy, as we know. It's necessary. But the inefficiency isn't. And our task today was to analyze the data which was being collected for the last 1.5 years for one of the furnaces. Now this furnace has like 5 process modules which we can use to process the wafers. Now from the data, after processing, we can see here is a very good pie chart which describes the amount of wet oxidation, dry oxidation, and annealing processes. So the waste oxidation, it was around 57%, 57.4%. So this was the most used techniques or the processes in this case. And we also calculated the total energy consumed, which was around 66,199.1 kilowatt hours. And if you compare it, like for 1 kilowatt hour, energy consumed, it's 420 grams of CO2 emitted. And this means it's around 27 tons of CO2 emitted every year. That means it's 120,000. It's 120,000 kilometers driven by a car. Now, can you go to the next? Okay, so this is one of the bar graphs. You can see here we have taken the top 20 most energy efficient recipes, energy intensive recipes. So there were around 68 of the unique recipes, but these were the ones which took or which consumed most of the energies, which is in kilowatt hours, you can see. And this is one of the bar graphs as well, which shows us, so there were like 5 process modules, and this is the average energy which is consumed by each process modules. And okay, so the conclusion. How do we optimize it? How do we reduce the energy consumption? What are the processes for this? So we can optimize the recipes which took the most, which consumed the most amount of energies. And those processes, maybe it ran for a couple of days or maybe a couple of hours, but consumed, it requires a lot of heat. So we can use maybe graph theories. This is one of the assumptions. We can use graph theories to automate the scheduling for the wafer batches. We can use that. Also, we can also do proper, like maybe we can reduce some of the temperatures from the processes, maybe your 10 or 20 degrees centigrades, if it is possible to optimize that in that way. So even like we have to focus on the smallest steps. We have to take the smallest steps possible, and we have to try to reduce the energy consumption in each step possible. And at the end, I hope that we can reduce the energy in a bigger scale. And that's how we can optimize the energy and go for a greener solution. So, thank you.